Good morning, good afternoon, and good evening, wherever you may be in the world. Welcome to this segment. Welcome to my channel where we interact with different concepts mathematically and scientifically to ensure that you achieve excellence in your academics. All right. So, what do we have on the menu? We have two questions under question 11. This is a continuation of our paper 2 mathematics exam preparation series, and we are still interacting with the Euclidean geometry, which is a challenging topic, but through these videos and presentations, I believe that I'm making it easier and fun for you to understand it. All right. So there are two parts to the question. Let us look at the first one, question 11a. Here you go. All right, so before we respond to the question, I just want to remind you of the inquiry method. This is a method where you generate questions about the question that you need to answer in order to fully understand it. All right, so it's an eye-opening and a mind-opening type of process that allows you to understand what is given. So by just looking at something on a maths paper, you'll need to be able to identify what is given. Okay, that is the primary question. What is this? We are given a diagram, and in this diagram we see a circle. All right, what do we call diameter, radius? Yes, given a center and get a center theorem. So those things come up as you look at this diagram. If at all we have a center and a diameter and a radius, that will be confirmed in the information that is given. All right, we have a cyclic quad BCDF. We have another cyclic quad BCFE. Okay, we have established that. What else do we see? We see split angles at B, two split angles, three split angles there. And we see chord BE is definitely equal to chord CD. All right, what else do we see? Okay, we cannot assume that that is a diameter or BF is a diameter. So if it is not said in the question, we cannot use that property of the circle as much as we have a circle. All right, so that is the what part of the inquiry method, whereby you are just saying what is in front of me, what can I recognize, what is familiar, what concepts, what points can I connect, and that helps you to definitely create a navigation from where you start to the finish point of the solution. All right, what must we prove? That the sum of angle C1 and C2 is equal to the sum of angle B1 and B2. Okay, so what is our point of departure? We are given a variable form of angle F3 there as x. Okay, we need to come here and talk about C1 and C2 and come there and talk about B1 and B2. Definitely, we will need to recall what? Properties of a cyclic quad. That opposite angles are what? Good. Supplementary. Okay. So let us start the proof. We are given that angle F3 is equal to x. This is given. Okay. And why is this significant that CD is equal to BE? It allows us now to connect F3 to F1, making F1 also equal to what? X. Because equal chords will subtend equal angles at the circumference of the circle. So BE will subtend X, or is subtending X, and therefore CD will subtend X at the circumference of the circle. All right. So therefore, it means that angle F1 is equal to X because of equal chords, equal angles reason for this statement, right? So that takes care of this connection that we are making, right? Now we want to come here. If you look at the sum of angles C1 and C2, it is an angle in a cyclic quad CDFB, okay? And how is it linked to this angle right here? They are supplementary, as we said initially. So we know that angle C1 plus angle C2 is equal to 180 degrees minus what? The sum of F1 plus F2. Okay? What is the reason for this statement? These are opposite angles of a cyclic chord. Okay? However, what is F1? This guy comes in there, right? This is 180 degrees minus x minus angle F2. You can just leave it there for now. Okay? Good stuff. Now, can we park that for now and go to B1 and B2? Yes. We have an x and we have an F2. And I have an x and F2. So that might lead us to equal expressions allowing us to equate the sum of the angles, all right? And what will we do now? We're going to talk about this angle right here. Okay, the sum of F2 and F3. Okay, it's a three-way split angle there. We just need to be careful as to what we take because we need to work in the right cyclic chord. Okay, so now B1 plus B2, we know that supplementary angles there as well, so it will be 180 degrees minus what? F3 plus F2. Okay, because these are also what? Opposite angles of a cyclic chord. Okay, but what is F3? F3, we have it from there, it was given as x. So this is equal to 180 degrees minus x minus angle F2. Is this expression the same as that expression? Yes. So does this allow us to equate these two guys? Of course. Therefore, the sum of angle C1 and C2 is equal to the sum of angle B1 and B2. All right. So that was the roadmap that we created through the inquiry to identify what is given, what do we see, what is familiar, what can we connect. All right. So if you start a question like that, especially in Euclidean geometry, it does help you to understand and unpack the problem much more effectively. All right, so this takes care of question 11a. Straightforward, easy stuff. So let us now go to question 11b and see what's on the menu there. Here you go. Good. So we are given a circle, a number of chords, some angles are given, and at some points there are split angles, two split angles here, two split angles there, F as well. And we need to find the angle here, F2. Okay, so what would be the roadmap and how we will navigate our way through this problem to get to the solution? Okay, the center is not given, we don't have a diameter, we don't have a radius, we don't have equal chords like the previous question, no cyclic chords. So what can we do? What can we do? Okay, somewhere it looks like there could have been angles in the same segment. I mean, if we get this 30 degrees, and if we get that, there's just no chord there, you can create a construction. And even there, if we construct there, you will see that you will have angles in the same segment like that. Okay, so we need a construction in this problem to be able to get to the solution. So for this presentation, I will choose this construction here where we join CF, right? Or you draw CF, okay? That is a construction. Now, what can we do? We know that if we've done so, we have that angle should be equal to that angle. So the 45 degrees is linked to that angle right there. Okay, so therefore FCD is equal to 45 degrees. These are angles in same segment. Okay, so we put the 45 degrees right there. Good. But then we have a tangent GB. Okay, the angle between the tangent and the chord, in this case FB, okay, the angle between the tangent and the chord is equal to the angle subtended by the same chord in the alternate segment. So what is the full angle there now? 75 degrees, making this angle also what? 75 degrees. So therefore B2 is equal to 75 degrees by what? 10 chord theorem. Okay, and we are now in triangle FBG. We have two angles in the triangle. Can we find a third angle? Yes, and therefore angle F2 is 180 degrees minus 75 minus 65 degrees, giving us a beautiful 40 degrees. And the reason here is interior angles of a triangle. Right. So yeah, this was an interesting problem. Remember, the construction that you make, or anytime that you make a construction, it should be effective. Don't just make construction for the sake of that. All right. So your challenge now, your homework, is to not use this construction. Use this one where you draw EB as a chord and prove that you will arrive at the same result. Okay, so this takes care of question 11, and now we are heading off to question 12. All right, so see you in the next video. Thank you for watching.